All right, today we're going to talk about the centroid of a triangle. And I'm going to make myself a triangle here. And remember that the centroid is going to be where the medians intersect, and that happens to be, as we know, is that we'll have to find the middle of a side and then take it to the opposite vertex, okay? And to find the middle of a side, we use the trusty old perpendicular bisector. So I want to make sure that I've got it more than greater than half the distance, and it looks like I do. So I got to hold my compass here so it won't move. This is one of the tricky things about doing these compasses, unless you got some real fancy-dancy one. All right, here we go. All right, so now I have just made a perpendicular bisector, and I'm going to come through here and find the exact middle point. So I come right through here, there. So that is the middle of this side. I take that and connect it to the opposite vertex. This is the angle, this is the opposite side. So I connect that, and there's my median. Now I'm going to do that to another side. Let's do this long one. All right, this may be a little bit harder to do, but let's see if I can do the long one. Let's see, get a little bit more longer, bigger, wide. Here we go. Just a little bit longer. There we go. So now I make an arc. Come back here, not changing the distance from the opposite vertex because I'm looking at that same side, trying to find the middle of this side. So I connect these, and there's my little line. And here is my center of that side. I draw a line to the opposite vertex, and there is the median. Therefore, these two medians cross right here. So what's convenient about and useful about the centroid, this is actually the balance point. So if I cut this triangle out and put it on the top of this pin, it would balance right there at that point. Okay, that's one of the benefits of that. The other useful thing, let's go ahead and do another side over here. I don't think I've done this side over here. And I'll show you another aspect. Well, I guess I can show you from right here. This right here, this length right here is actually 1/3, and this is 2/3 of the distance from this side, from this vertex to this opposite side. That's one of the things that the median does. So if this is, say, an x plus 2, and this right here is 2x plus 7, let's say, then in order to make this side equal to this and to solve for x, to have an equation, I'll have to multiply this by 2, since this right here is 1/3 and this is 2/3. All right. Likewise, this leg right here is going to be 1/3, and this right here is going to be 2/3. In this case, if I have this total distance given to me as some number, let's say x plus 7, all right, and then this distance right here, and I got to set this equal. So this right to solve for x, let's say this is 2x plus 7, or not 9, all right, 9, let's say. Then in order to make these equations equal to the whole distance, which is 3/3, and the distance of 2/3, all right, I'd have to multiply this side by 3/2 to make these equivalent to each other. So therefore, I can set up an equation. All right? Thank you. So that's a little bit about the centroid.